Okay, this video is on the triangle sum theorem and the exterior angle theorem. Now, the triangle sum theorem we've already talked about says that the sum of the measures of the interior angles of any triangle is always equal to 180 degrees. So let's take a look at a few examples of this one. Here I have a triangle and I know the measures of two of the interior angles and I want to find the third. A lot of students find that the easiest way to do this is just add together the two interior angles that you have. That gives you 120. You subtract that value from 180 and you get 60. So this third angle here must be 60 degrees. Now for this one right here you could also do that, except it's maybe easier in this case. I have a 90-degree angle and then I have two angles here. The other two interior angles are labeled x. This one, it may actually be easier to actually set up the equation based on the triangle sum theorem. The sum of these three angles, 90 plus x, is equal to 180 degrees. Now I can collect my like terms, subtract 90 from both sides. It gives me 2x equals 90, and I divide both sides by 2, and I have x equals 45. So I know this angle must be 45. And this angle must be 45. Example number 3 we see is a little bit different. Here I've got one large triangle and it's kind of divided up into these two smaller triangles. Well, if I look at just the large triangle here, then I can see that the value of this angle right here is going to be 2x. So I have the value of this angle. I also know the value of this angle is 50. This angle is also 50. So again, I can set up my equation. 2x plus 50 plus 50 equals 180. That's what my triangle sum theorem tells me. So now I've got an equation. I collect up my like terms. 2x plus 100 is 180. Subtract 100 from both sides. 2x equals 80, and I divide both sides by 2, and I get x equals 40. Now, in example number 4, we have a triangle here, and now I'm looking not for one of the interior angles, but I'm actually looking for this angle here that lies outside the triangle. So I know that this symbol here tells me that this angle here must be 90 degrees. So based on this, I can determine the value of this angle. And then once I know the value of this angle, I can find the value of that angle. So let's see. Let me call this angle, let me give this a name. Let me call this angle y. So now I can write an equation. 50 plus 90 plus y, that's that angle, equals 180. So 90 and 50 is 140. I have 140 plus y equals 180. Subtract 140 from both sides. And that gives me y equals 40. So now I know the value of this angle here is 40. Well, notice that this angle and this angle form a linear pair. So I know that the sum of these two angles must be 180 degrees. So I can say 40 plus x equals 180. Subtract 40 from both sides. And that gives me x equals 140. So now I know the value of x is 140. Now, this angle right here, it actually has a special name. It's called an exterior angle of a triangle. And that's what we're going to talk about here in this section. Interior and exterior angles of a triangle. Now, here I have a picture of a triangle, and I've actually extended the sides out of the triangle so that it forms these extra angles here on a triangle. So you can see angles 1, 2, and 3 on this triangle, which I've got in orange. Angles 1, 2, and 3 are called interior angles. So angle 1, angle 2, and angle 3, those are all interior angles of a triangle. An exterior angle of a triangle, that's these angles that I have labeled here in green. So angle 4 and angle 6 angle 7 and 9, angle 10 and 12, these are all called exterior angles of a triangle. So angle 4 and angle 6, angle 7 and angle 9, angle 10 and angle 12, angle 12. Those are all called exterior angles of a triangle, and notice they all lie outside of or exterior to the triangle. Now, notice I've got these other three angles here. These also lie outside the triangle, so you might think that those three angles would also be called exterior angles, but in fact, they're not. Angles 5, 8, and 11, these are not exterior angles. Angle 5, angle 8, and angle 11. And the reason these angles are not exterior angles is because exterior angles have a particular property. Not only are they outside of the triangle, but exterior angles must form a linear pair with one of the interior angles. So you can see all of the angles that we've labeled here as exterior angles, they all form a linear pair with one of the interior angles of the triangle. And these angles here in red, those are not exterior angles of a triangle because they don't form a linear pair with any of the interior angles. In fact, it turns out they're all vertical to one of the exterior angles, one of the interior angles of a triangle. So let's see how, well, first we're going to define exterior angles, and then we're going to talk about some other angles of a triangle. And then we're going to see how we are going to use these angles to solve some additional types of geometric problems. So an exterior angle of a triangle is an angle that forms a linear pair with an interior angle of a triangle. And here we see those, the same picture that we had on the previous screen. So the exterior angles, they all form a linear pair with an interior angle of a triangle. Now we also have something called the remote interior angles of a triangle. And a remote interior angle of a triangle, there's actually two of them for each exterior angle. A remote interior angle of a triangle, that's the two, actually I guess this should say the remote interior angles of a triangle. The two interior angles that do not form a linear pair with an exterior angle of a triangle. So let's say we take exterior angle number 4 here. The two remote interior angles that are associated with exterior angle 4 would be angle 1 and angle 2, because angle 1 and angle 2 are the two interior angles that do not form a linear pair with this angle. Now if we look at this exterior angle here, then the two remote interior angles associated with angle 7 would be angle 2 and angle 3. Now, the exterior angle theorem, and that was actually one that we kind of saw it in the previous example. The exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of its two remote interior angles. And in fact, if you look back at this example number 4 that we just did, notice that when we got our answer here for this exterior angle, which is 140, notice that 140 is equal to the sum of the two remote interior angles. So this angle is an exterior angle. These two angles are the remote interior angles associated with this exterior angle. And you can see the exterior angle is equal to the sum of these two remote interior angles. So now let's take a look at some examples that make use of the exterior angle theorem. So example number 5, I have a triangle. I have a value of an exterior angle here is 120. And then I'm looking for the value of these two remote interior angles. Well, I can use my exterior angle theorem, which tells me that the measure of this angle must be equal to the sum of these two angles. So I have 120 equals 2x. I divide both sides by 2, and I get x equals 60. Now notice in this particular example, I could have solved this problem without using the exterior angle theorem. I could have just found that the measure of this angle must be 60 degrees, since that forms a linear pair with this 120 degree angle. And I could have said 60 plus x has to equal 180 because of the triangle sum theorem. So I've got 60 plus 2x equals 180. Subtract 60 from both sides. And I get 2x equals 120. And again, I have x equals 60. So I could have done this problem without using the exterior angle theorem. All right, take a look at example number 6. Here I have an exterior angle. I'm looking for the value of this exterior angle of a triangle. I know from the exterior angle theorem that the measure of this exterior angle is equal to the sum of its two remote interior angles, which means this angle and this angle. I don't have a value for this angle, but I can see that it forms a linear pair with this angle, which means that this angle here must be 180 minus 145, which is 35. So the measure of this angle is 35 degrees. Now I can use my exterior angle theorem and say x must be equal to 65 plus 35, which is 100 degrees. Now again, example number 6, you could say, well, I could have figured this out even without using the exterior angle theorem, because once I know that this angle is 35, I can add these two angles together and get 100, subtract that from 180, which tells me that this angle here must be 80 degrees. These two angles form a linear pair, which means x must be equal to 100. So you might start to get the impression that, well, I don't really need this exterior angle theorem to solve problems. I can just do everything with my triangle sum theorem and linear pair angles. And that's not quite true. Let's take a look at example number 7. Now here's an example where I'm looking for this value of x, and I have a triangle here. I don't know the value of this angle, but now it's kind of difficult for me to find a value for this angle so that I could use the triangle sum theorem. And instead, if I use the exterior angle theorem, well, it's a fairly simple problem. The value of this exterior angle is equal to the sum of its two remote interior angles, so I can just write that equation. The value of the exterior angle equals the sum of the two remote interior angles. Now I have an equation and I can solve for x. Let's see, let me add 22 to both sides. Gives me 3x equals x plus 102. Subtract x from both sides. 2x equals 102. And I divide each side by 2, and I get x equals 51.